Thanks for joining me for this session on Can You Keep a Secret? Very excited to be here. It's my first time at PyGotham, so I'm really enjoying it so far. My name is Aaron Bassett. You can find me pretty much everywhere as Aaron Bassett because I have no imagination. So Twitter, GitHub, all the rest, probably still on Bebo somewhere. I'm a developer advocate for a company called Nexmo. So Nexmo is a telecommunications API company. And my job there as a developer advocate means that I spend a lot of my time writing code. You know, examples, demos, workshops, tutorials, conference talks, you name it, I'm kind of writing it. All of it kind of demoing our products. Now, because this code is stuff that we're trying to develop to highlight what our products can do for our developers, everything I write is open source. And everything I write is also developed open as well. So it's all getting pushed out to public repositories all the time, which, if you look at the code here, can be a little bit of a problem. So in the code here, we have an API key and an API secret. So these are things that I use to connect to the Nexmo service in order to authenticate myself. It also has a telephone number. Anytime I'm doing these demos, I'm probably going to be sending messages to myself. These are not things that I want to display publicly. I'm just going to pause for a second and also say for any of the mischievous people in the audience right now, that's not my actual API key and secret, so don't bother. Also, that's not my real telephone number. That is one of the Ofcom reserved numbers for TV and radio broadcasts. It's like the example.com of telephone numbers. So you can stop trying to call it. It's not going to ring while I'm on stage, I hope. No, we're good. It's OK. So yeah, so these are details I don't really want to be publishing publicly. Now, normally, whenever I'm creating a piece of example codes, I'll try to be a bit tidier. I'm not going to just put the details in line. I'm going to assign them some variables. I'm going to put the variables probably somewhere near the top of the script with every intention of doing something to get them out there. I'm going to put them in a config file eventually. But what really happens is they live in my script like this, and eventually at some point I'm just going to I'm going to go for lunch, or I'm going to finish up for the day, and I'm going to want to save my progress, and I'm going to push up to GitHub. I'm just going to forget it's there, and I'm going to push up. And really, as soon as that happens, I have to treat those as compromised. And the reason for that is there is a research paper published written by Michael Melly, Matthew McNeice, Bradley Reeves from the North Carolina State University called "How Bad Can It Get?" Characterizing secret leakage in public GitHub repositories. Now, this research paper showed that the median time for discovery for a secret published to GitHub was 20 seconds. And it could be as low as half a second. Essentially, the only limiting factor for how quick they could discover secrets was how fast GitHub could index them from new code commits. So some of them they found the longest time was up to about 4 minutes. There was no correlation to time of day or anything like that. It was just essentially how busy GitHub was at that point and how quickly it could index new code. But as soon as it was indexed, it would then become available via the GitHub search API. And if you crafted your search queries in just the right way, then you could start lifting secrets out very quickly. So this is not new news. We're all aware of this, so we shouldn't be putting our API keys hard-coded anywhere, that once they're leaked, then we should treat them as compromised, etc. So why do we keep doing it? Because it's very easy. It is the most frictionless way of getting our variables in there we need to use. We see examples of this constantly in blog posts and tutorials and even installation guides for different libraries. They all have these variables or placeholders for the variables in line because managing secrets can be difficult. And just including a variable in a file is really, really easy. But it's this trade-off that we have. So they talk about this kind of security triangle. So the security triangle is made up of security, functionality, and usability. And as one of them increases, or two of them increase, then one has to decrease. If you have an app that is has lots of functionality and is very usable, it probably isn't very secure. But at the same token, if you have an app that is very secure and very usable, it probably doesn't do very much. And we see this in Amazon's their one-click purchase. So you go on Amazon, you find what you want to order, you click one button, and you don't need to do anything else after that. It's one-click buy. That's an additional functionality that they're implementing at the cost of security. Whenever you order via Amazon using the one-click, they are not sending the CVV, those 3 digits in the back of your card, along with that transaction. They're assuming that additional risk because they think the additional functionality is worth it. Now, about 10 years ago, I worked for a, thankfully now defunct, agency that thought that storing users' plain text passwords improves usability. They thought that having a user be able to call up the call center and have an agent read out what their password was, rather than doing a password reset, made for a better, more usable experience. I think it made them idiots, but yeah, potato, potato. So we can see then as we increase things in usability, then obviously something else is going to suffer. And that's going to be a bit of a theme in this talk, is like a lot of things we're going to look at, I want them to be low friction. You know, we're not going to be implementing IAM rules or doing lots of like audit logs or being able to track access or anything like that. This is things that you can implement now, today. You know, go to your projects and 20 minutes you can have all of your secrets out of your codes and somewhere where, okay, it's probably not something you're going to be using in production. You know, it's not going to have like different access level roles or anything like that, but at least your API keys and things are going to be a little bit more secure. So when researching into this, the first thing that comes up is this idea of 12-factor apps. So if anyone's not aware of 12-factor, it is a methodology for designing and enabling web applications to be built with portability and resilience when deployed to the web. Now, 12-factor apps have, as the name suggests, 12 different factors that you can go through. You know, code-based dependencies, config, backing services, build, release, run, et cetera, et cetera, et cetera. The only one that we're going to look at today is config. That's the only one we're really interested in. And the reason for that is what they state about this kind of litmus test for whether you've done your config correctly for your app. And that's if you've done your config correctly, factored out of the code is whether the code base could be made open source at any moment without compromising any credentials. And that's kind of what we're looking to achieve. You know, that idea of, okay, I'm writing a little example script and I accidentally push it to GitHub, it shouldn't matter. You know, if I accidentally turn my private repository public, it shouldn't matter. You know, if there is some kind of vulnerability in whoever's hosting my repositories and suddenly they're available online, it shouldn't matter. You know, our code repositories shouldn't have any secrets stored in them that are accessible to anybody but those people who should have rights to them. If we are creating our apps correctly, if we're storing our secrets correctly, then, okay, a source code leak is probably not something that we want, but it shouldn't compromise any of our other vendor accounts, et cetera. So, 12-factor apps suggest that all configs should be stored in environment variables. For anybody who's not aware of what an environment variable is, an environment variable is essentially a place that you can store variables that is out with the codes in the local environment, but is accessible to any scripts that are running within that environment. And what I mean by accessible is if you look at that same code that I had up a moment ago, we now have this OS environ and then a key. So the OS environ, it's worth noting that our environmental variables are mapped to OS environ the first time that OS is imported. So if you need an environment variable to be available to your script, it needs to be within your environment before you execute the script itself. You know, if you've made changes to the environment variables outside of the script while the script is executing, they will not be reflected in your code. So it's very important that you have your environment variables set up before you execute your code. Now, the mapping that goes on between your environment and OS environ is essentially a dictionary. So you can access it much as you can with dictionary using keys. You can also use get. So same as you could with any other dictionary. Obviously, one of the differences you'll get with using get is that rather than, if a key is missing, rather than raising a key error exception, it's just going to pass back none instead. For some people, that might be an advantage. Other people might want it to raise an exception if it's missing some config. You can decide for yourselves. It also means as well that if you're using kind of get in here, you can pass in defaults. So you can pass a second parameter to the get method, which will be used as default if the key doesn't exist in the environment. And what you might see some people use is get-env. So os.get-env rather than os-environ.get. So I actually did a little bit of research trying to figure out what this os.get-env, what the difference between this and running get on environ is, and it's none. It's literally a wrapper around os.environ.get. So maybe if you want to save some keystrokes, you might want to use that instead. I don't know why we've got two ways of accessing this. Doesn't seem very Pythonic, but we do, and some people use it, so I thought I'd better show both. So this is how we can access these environmental variables within our scripts. But whenever we come to creating the variables, remember what we said about importing OS, we need to ensure that all the environment variables are available before we import OS. So we need to have these environment variables created within our local environments. Now, if you're using virtual env, you can actually do this within your bin activate script. So your bin activate script is kind of back to forward, but the first thing you've got is this deactivate function. And the deactivate function will be called whenever you deactivate your virtual environment. So within the deactivate function, then you can unset any of these environment variables that you've set. So essentially, you can clean up and do a little bit of housekeeping. What you can also do within the actual main body of the bin activate script is export all these environment variables. So you can set them within your environment. So here you can see I'm setting up my nexmo key, my nexmo secret, and my number. So whenever I activate my virtual environment, these environment variables will then be available to my script. Whenever I deactivate my virtual environment, it's then going to run that unset, and it's going to clean up after itself. I personally don't like this approach. I treat my virtual environments as if they're disposable. I very rarely alter or manually alter any of the files within a virtual environment. So I'm not overly keen on this particular approach, but that's personal preference. What I prefer to use is a application called dir-env, or directory env. That's an extension for your shell that will load and unload environmental variables depending upon your current directory. So essentially, whenever it encounters a .env.rc file, it's going to load that into your shell. So you cd into a directory. If that directory has an env.rc file, then it's going to load that. And that looks a bit like this. So here, I'm creating an env.rc file. I'm echoing a export nexmo key into it. And, oh, it throws an error. This is a security function of dir-env that it's not going to just run any .env.rc file it comes across. You don't want it to execute anytime you change in the directory of like the latest thing you've downloaded from GitHub or some folder that you've just unzipped, etc., it would be a security vulnerability if it just immediately executed the script. Instead, what we have to do is we have to go allow. So I'm going to tell dir-env that it should run for this directory. It's saying I'm going to reload. It's going to load all of my environmental variables, all these export functions into my local environment. And I'm going to leave that folder. When I cd out of it, it's also going to unload them. So it's in the same as the activate, deactivate, but I now have this env.rc file that's within my project folder, not within my virtual environment folder. If you are going to go this route, I would recommend that you ignore all env.rc files using your get ignore global, so you don't accidentally check one of them up into your repository. You also probably want to share an example env.rc file, so that whenever you're sharing your code with other developers, they'll know what environment variables your script is expecting to be set. Now, all of these are about what the keys are going to be, but what if you need to share actual values, or what if you need to share files? What if within your team you have an SSH key or some other kind of private key or some kind of authentication to a vendor that you want your team to have access to, but if the source code was to leak, like we talked about previously, you wouldn't want anybody else to be able to access it. Or, an example coming from ours again, if we're using like our API to make a telephone call, it's pretty much the same as it was before. We've got like telephone numbers and stuff in there, but we also have this nexmo private key. So this is a key that's required by the application to authenticate to make a call. So that will probably differ project to project, but in some cases we might share that with a team. But we do not want anybody else outside of that team to be able to use that key. We trust the members in our team not to abuse our account, but if that key was leaked publicly, then we'll have people using our nexmo credit to phone like premium rate numbers, and I don't want that bill. So we want a private key to remain private to the public, but be accessible to the rest of our team. And that's where get secret comes in. So get secret can be used to encrypt files and stores them within your Git repository. Now, I know at the start I was like, the very important thing about this talk is that we want to remove friction, things should be really easy to get going with. And for the most part, get secret is safe and easy. Ish. Get secret itself is pretty straightforward to use. It does use PGP though. For anybody who's not come across PGP before, it's pretty good privacy. It's actually really good privacy, but it's a bit clunky to use. I'm not going to go into key signing like parties or the, creating the secure web of security, sorry, and things like that. Yeah, there's a lot of things and fiddly things to get it set up with. It is what GitSecret uses to do the encryption. It's also how it manages users that should have access to files. So you will need to have PGP installed on your machines. You will need to have every member of your team generating their public and private PGP keys so they can share the public ones with you. That's a whole other talk by itself. But let's assume you're already using PGP or you've got it set up and it's getting to GitSecret stuff. So GitSecret, like Git itself, you do GitSecret init. It's going to create a directory within your Git repository called GitSecret. I can then tell it who should have access to any secrets within this repository by specifying the email address associated with the public key. So here I'm just using my email address. And then I can start adding files that should be hidden. So I'm going to use the example we had before. We've got a private key, and I'm going to add that as a file that should be secret. So this is going to be something that is going to live within the repository, but it's going to be encrypted. Now, the private key file itself, whenever GitSecret does the encryption, it doesn't encrypt in place. That is, it doesn't overwrite the existing file. It creates a new file. So what we don't want to do is also check our source file, our essentially unencrypted file, into source control as well. So what GitSecret will check whenever you first add a file is one to be hidden, that it's currently in your gitignore. Now, if that file is not in your gitignore, it'll add it in for you to ensure that you never check in the actual source file, that you're only ever checking in the encrypted files. So if I cap my gitignore file, we can see that GitSecret's added a couple of other lines in there. You know, it's ensuring that its random seed is not being uploaded, and it's got that private key in there too. If I do an ls at this point, I can see I've got my Git folder, I've got my gitignore that it created, I've got the GitSecret directory that has things like that random seed in it, and I have the private key. Now this is a source file still. This is unencrypted. If I run gitsecret hide, at this point it's then going to run through all of the files I've added, and it's going to encrypt them. And it's going to create a new file, which is filename.secret. So in this case, private key.secret. Now this private key.secret is the encrypted file, and this is the one that we can check in the source control. You know, this has been encrypted with PGP using the public keys of all of the people that we've added in as people who should have access to the file. This file is perfectly safe to share wherever you want to share it. You know, so you can add this to your repository, push it up. Again, if your repository is compromised or your source code leaks, etc., all they'll have is an encrypted version of your key. They won't have the source file. Then whenever any of your colleagues download the repository, they just run gitsecret reveal, and it'll decrypt any of the encrypted files if they've got access rights to it. So it also comes with a couple of other little helpers for it. So we have gitsecret who knows. And gitsecret who knows will show you the list of people that currently have access to any secrets stored in the repository. This is really good if you need to do any kind of auditing about who has access to a particular file. You know, if somebody's leaving the company, etc., you can go through and see exactly which files you need or which keys need to be rotated, which ones they had access to. Speaking of which, if you need to revoke somebody's access, there is the very morbid gitsecret kill person. That's one way of revoking their access for sure. So the kill person will remove them from the list of public keys that should be used to encrypt any future files. However, it will not re-encrypt any existing files for you automatically. So that person, while they will no longer be able to read any files going forward, any existing files, they will still be able to decrypt them. So and what it reminds you to do there is if you've done this, is you need to decrypt all the files. So run gitsecret reveal, and then encrypt them all again with gitsecret hide. And what you'll probably also want to do in this instance, if somebody is leaving the company, etc., is probably rotate those keys anyway. So you'll be doing a reveal and an update, and then hide as it is. Okay, so now to really confuse you, that was gitsecret. We're going to talk about gitsecrets, because the people naming these packages have even less imagination than I do. So gitsecrets is not really about how you can store secrets. It's about ensuring that the methods that we've talked about earlier, that you're actually using them and they're being enforced. So gitsecret scans commits, commit messages, no fast forward merges to prevent you from adding secrets. Okay, so it's going to use, it uses git hooks and it uses regexes to look for particular patterns within your source code. And if those patterns are found, then it will prevent you from committing that code to your repository. So once it's installed, we run gitsecrets global to register for our machine. Then we use gitsecrets install to generate our git templates. So for people who've not used Git templates before, whenever you do a git init, it's using a set of template files to generate what should be within your kind of your .git repository. Within those, there is some example hooks that are not activated. This generates a series of Git templates where the hooks are activated, and they're set to use Git secrets to run these regexes. So we generate our template files, and then we tell git config global that these are the templates we want to use anytime we create a repository from now on. So from that point forward, anytime that we run git init, it's going to create a new Git repository, and it's going to ensure the webhooks are activated. And these webhooks are the ones that are going to run our Git secrets and check against our list of regexes. Now, Git secrets is from AWS. So it's from AWS Labs, sorry. So the only regexes that it comes with by default are those who detect kind of AWS keys. But it has an idea of providers. So providers is a way for you to specify your own regexes that you want to check against like any new code commits. So the way in which you have providers is it's a list of regexes, one per line. What their suggestion is you have a file with all your regexes in it, and then you just cat that file as your ad provider. My issue with that is, okay, so some of them are pretty easy to tell what it is. You know, we can probably all of us look at this regex and go, that's for detecting an RSA private key. What about this one? Anybody recognize this one? Not a single hand. So that is for regex for detecting Google OAuth access tokens. Anybody? No. Facebook access tokens. You know, you're never going to remember what these things are if you don't have any way of easily identifying them. It's just a list of regexes. You're not going to know which ones you need to change, which ones are no longer valid, etc. So the way in which I do the providers is instead I have a folder which contains a series of files broken down by what type of regexes it is. So I might have one that contains regexes for detecting different cryptocurrency keys, one for detecting different keys or certificate perms, one for different vendors, you know, like Facebook, Google, etc. Within those files, then I want to have some comments, you know, so I can go, these keys are for Slack, you know, be able to add additional lines in to break it up a little bit, make things more readable. So when I come back to this later to add additional regexes or to maybe amend one that's currently in there, I know which one I'm looking for. Now, obviously, whenever I supply these back to Git secrets, if I still have comments and new lines and things that are blank lines, it's going to choke on it. So I kind of just use cat. So instead, I'm going to use ENCRYPT. And ENCRYPT, I'm also using a regex there to go, don't give me any lines that start with a hash or just an empty line. So it's going to filter out all of those comments, it's going to filter out all of those empty lines, and it's going to provide me back with the same thing as we had before. Now, if we look very quickly at then what happens when we try to commit something when we're using Git secrets, this is what we get. You know, I'm trying to add a private key here. The private key matches one of the regexes that I supplied, and we now have this block. Now, Git secrets will show us how that we can override that. You know, it is possible that there will be false positives. You know, you may have some examples, code, etc., that might raise it. There's a whole list of things there that shows you about how you can allow these through. So it's not going to completely prevent you from adding secrets into your codes, but it's going to be a good first pass to try and prevent you from doing something overtly stupid. So I think I've got time to go through one more. I've not had my 5-minute warning yet. So I'm going to move on to GitLeaks. So GitLeaks is kind of your last line of defense. There we go, now I have it. So GitLeaks is your last line of defense. GitLeaks audits your Git repos for secrets. You know, so this is actually what would happen after you've finished coding and you've pushed up. You know, so we're hopefully this will never occur, but we want to make sure that we are covering all eventualities. So GitLeaks, you can provide it with like a Git repo, a GitHub user, an organization, even a GitHub PR, so pull request. So you can include this as something that needs to pass in order for your pull request to be merged. It operates in very much the same way as Git secrets, you know, using these regexes to look at your codes, but you can specify like an entire organization. So go through every repo in an organization and check the code. Or only look at this one pull request and tell us if it can be merged or not. It provides a nice little report afterwards. So you can see exactly which file in which repository and which commit broke the rule, which rule did it break. And in fact, whenever there is a rule broken, we can use the exit code of GitLeaks to do some automation as well. So there's a little bash script I wrote last night. It runs GitLeaks against an entire organization, so it downloads all of the repos in the organization. It then looks for the exit status of that function. So GitLeaks is going to report back a 0 if there's no leaks. If there is a leak, it's going to report back either a 1 or a 2. So at that point then, we have this nexmo SMS. So essentially I'm going, something in one of our repositories is leaking. I'm going to text all our developers, let them know, and they can then go and check that report and find out what's going on. So to sum up very quickly, keep secrets and code separate. If you do this, you're like 99% of the way. If you need to share secrets, encrypt them first. Bearing in mind, PGP is awful sometimes, so use tools to make it easier. Automate, automate, automate. Like, you want to make it as easy as possible to keep your secrets out of your code, and as hard as possible to revert back to your old ways. And late is better than never. Okay, what you're aiming for is never to check secrets in, but if you do happen to check secrets in, it's better to detect them at CI/CD level or in your CS afterwards. So I've been Aaron Bassett. Thank you very much for your attention. I'm not going to be taking questions, but we are on the nexmo booth in the hallway, so if you want to ask me anything, I'll be happy to answer it there. Thank you so much.